This lesson's about multiplying polynomials. A common mistake in regards to multiplying polynomials is trying to just multiply the like terms. Again, this is a common mistake, but some people will just try to multiply the 2x and the x together, and that would give them 2x squared. And then they just want to multiply the 3 and the 5 to get 15. And they say, hey, the answer is 2x squared plus 15. The reason that's incorrect is because if 2x plus 3 times x plus 5 truly equaled 2x squared plus 15, then you should be able to pick any number to plug in for x in either situation, multiply them together, and get the same answer. So let's say, for example, we choose the number 3. So if we plugged in 3 into the original problem, I would have 2 times 3 plus 3 in the first set of parentheses, and have that times 3 plus 5 in the second set. 2 times 3 is 6 plus 3 is 9, and 3 plus 5 is 8 for a total of 72. But if you try to plug in that exact same 3 into what we think the product is, you would have 2 times 3 squared plus 15. You have to do the exponents first, so 3 squared would be 9, so you'd have 2 times 9 plus 15. 2 times 9 is 18, plus 15 is 33. And you can see those clearly are not the same. So this is not the way that you're supposed to multiply polynomials. To multiply polynomials, such as 2x plus 3 and x plus 5, the distributive property is used. Yes, this is still a distributive property question. So in this case, when you use the distributive property, you're going to multiply the first term times both terms in the second set of parentheses, and also the second term times both terms in the second set of parentheses. So the proper way to do this one is to do 2x plus x, which is 2x squared, and we did do that. But you also have to take 2x times 5, and that is 10x. Then you would also take 3 times x, which is 3x, and then 3 times 5, which is 15. And then oftentimes you have to combine like terms, which are usually in the middle. So that would be 2x squared plus 10x plus 3x is 13x, then plus 15. And that would be your answer because there are no more like terms. And to verify that, I can remember the 3 that we plugged in up here. I could plug in 3 in for x squared to show you that this is the proper way of doing it. So that would be 2 times 3 squared plus 13 times 3 plus 15. So 2 times 3 squared is 9 times 2 is 18. 13 times 3 is 39 plus 15. And 18 plus 39 is 57 plus 15 is 72, which is the exact same thing as we got up here in the original problem right there. So that is the proper way of doing it, doing a distributive property. Sometimes I'll call that double distribute. In some cases, you'll hear it referred to as FOIL. If you have seen the FOIL method, it works fine. I don't particularly like calling it FOIL, so I won't be using that term. But it is more like a distributive property. That's all it really is, where you take both terms in the first set of parentheses times both terms in the second set. So a couple more practices. We'll take x times 3x, and that is 3x squared. Take x times 4, and that is 4x. And now take negative 2 times 3x, and that is negative 6x. And take negative 2 times 4, and that is negative 8. And then our combine our like terms. We have 4x times negative 6, or plus negative 6x, that's negative 2x, and then minus 8. Lots of places to make mistake on these. Lots of places you can forget an exponent or switch a plus or minus sign. So make sure you're working carefully. 4a minus 5 times 2a minus 9. So 4a times 2a is 8a squared. 4a times negative 9 is negative 36a. Then negative 5 times 2a is negative 10a. Negative 5 times negative 9, that's positive 45. Then add my my like terms. Negative 36a minus 10a is negative 46a, and then plus 45. Notice that when two linear expressions are multiplied, the result is a quadratic expression. A quadratic expression is an expression in one variable with a degree of 2. After we get done with this Algebra 1 review, we will cover an entire chapter that is nothing but quadratic expressions. They are very important. There's lots of real-world applications we can use for quadratic expressions, and so that's why we're spending a lot of time just studying how to get quadratic expressions. Now, not every time that you multiply do you get a quadratic expression. Sometimes the exponents will be higher, as shown here in example 4. This time we have a binomial with 2 terms in the first set of parentheses times a trinomial with 3 terms in the second set of parentheses. So we have to take both terms in the first set times all 3 terms in the second set. So that'll be 6x times 2x squared, and that is 12x to the third power. 6x times negative 3x is negative 18x squared. Remember, we're adding those exponents. 6x times negative 5 is negative 30x. And now take 5 times all the terms. 5 times 2x squared is 10x squared. 5 times negative 3x is negative 15x. And 5 times negative 5 is negative 25. We have several like terms on this one. There are no like terms with 12x to the third power, so I'll just bring it down. And I'm going to put a little cross through there, a slash through there to remind myself I've already used it. But I do have negative 18x squared and positive 10x squared. When we add those together, we get negative 8x squared. Then I have negative 30x and negative 15x. Add those together to get negative 45x. And then finally, the negative 25 is the constant. No other constants, so I just bring that one down. And no more like terms, so that is the polynomial answer. One more. 3x times 2x squared is 6x to the third power. 3x times 7x is 21x squared. 3x times negative 8 is negative 24x. And now take negative 5 times 2x squared is negative 10x squared. Negative 5 times 7x is negative 35x. And negative 5 times negative 8, that is positive 40. Combine like terms, no other like terms with 6x to the third power. But there is a 21x squared and a negative 10x squared, so when I add those together, I get positive 11x squared. Negative 24x and negative 35x is negative 59x. And then finally, bring down the constant 40.